Yeah, a bit of my background. Um, after high school, I did 2 years of mechanical engineering at the British Columbia Institute of Technology. While I was doing that schooling, I was working at the Chilliwack Honda motorcycle shop, and I was in service and parts there. And as a motorcycle enthusiast, that was kind of uh, an excellent job at the time, and I had a great time, learned a lot from that experience. Um, and being part of a family business, my father founded our company, Klassen Specialty Hydraulics, in 1991. We've been the Canadian distributor for CC Jensen since '94, and just this spring we changed our name to Klassen Advanced Filtration to better reflect our core business. Now, as anyone who grew up part of a family business knows, there's often very little separation between work and personal life, and our family was certainly no exception. Oil filtration and contamination issues was a constant topic around our dinner table. So I became immersed in it from quite a young age. Since then, we've grown from a literal mom and pop operation to now having 4 full-time and 3 part-time employees. And we're serving all major industries in Canada from coast to coast to coast. So our major markets include mining and oil sands, power generation, marine, pulp and paper, and manufacturing. So that brings us to my presentation today, varnish. And naturally, we should start by defining what is varnish. Unsurprisingly, if you talk to most of your friends, this is what they'll think of when you ask the question or start talking about varnish. And naturally, you are a group of lubrication and tribology engineers, so you know a lot about varnish already. So, of course, this is the varnish that we'll be talking about today. Um, and we've learned a lot about varnish over the last couple of decades. I'll take you on a little bit of the journey that we went on here at our operation in Canada. Um, Probably one of the first major learning experiences came in 2002, and we were working on a bale press at a pulp mill that was experiencing some issues, and we sought to try and help them with that. And using some of the kidney loop filtration systems, we started to purify it, and while we were doing that, we realized that this was more than just particulate contamination. We were dealing with some other stuff going on here. One of the tools that we used at this point was the ultracentrifuge, which you can see here, and we were just capturing things that we hadn't really seen before. So we learned a lot from this process. We filtered the oil for about 12 months, and we saw that nice bright looking clear sample there, and the mill figured, okay, we're done here, so we don't need to spend this money on filtration anymore. And they took the filter off, and 6 months later it was looking just about as bad as before we had done anything. So what was going on? So that that kind of pushed us onto this quest of learning more and more about varnish. Over the next number of years, um, we tried to learn as much as we could. We commissioned reports, we talked to experts, we conducted experiments, we used different filtration configurations, different filter media. We analyzed and interrogated whatever we could. And we did learn a lot. For one thing, we learned that a single filter cartridge could capture in excess of 15 pounds of varnish. And it wasn't trapped on the surface of the filter, but it was absorbed throughout the fibers of the filter. So it was an extremely strong bond, and that was some vital knowledge. So we kept working with it. I would say the next big revelation we had was working with a gas turbine in Fort McMurray, and we were confident that we could improve the system. Again, they were seeing some issues with varnish, and we brought a little test filter cart along, took a small sample of oil out of the turbine, and began to filter it. and we filtered it for about 30 hours. And we had a look at the sample from where we started, and we thought, wow, this is great. So we, had a nice dinner that night and went to the hotel. And in the morning, we thought, okay, we're going to document this. We're going to take some pictures, and realized that we had forgotten the oil sample in the truck. And this was Fort McMurray in the winter. So we went out to get this freezing sample of oil and set it on the counter, and we thought we must have made a mistake. This oil was not the same as what we had just been working with. It was cloudy, and it did not have the clarity and the crispness to what we had seen the day before. And then we started messing around with temperature and warming it up, and realized that this can have a big swing on how the samples look. So this was the same sample at the left on at 25 degrees C, and at the right at 0 degrees C. And that got our gears turning, so we started doing some more work with that. Um, Eventually, or by the end of this particular project, we continued the accelerated test from where we thought we had finished. At this time, keeping it at a constant temperature, and again observed the clarity change to the samples. So this was a big learning experience for us. Um, from there, we were doing some more work with it at some other sites. We came up with a prototype design using a little bit different configuration, and a few other things that we had come up with. And things were working actually pretty well. Things were heading definitely in the right direction. We were sharing this information as we were learning with the manufacturer in Denmark, their engineers there, um, and learned that they were also working on a specific varnish product. So we were comparing notes with what we were doing there. And in 2010 was the commercial release of what we called the varnish removal unit, or the VRU. And this was kind of utilizing all the knowledge that we'd gained over the previous years, and we saw some remarkable improvements. So this was a gas turbine filtration. This is the stack of used filters from our previous style of filtration, just a basic kidney loop. And running on the same system simultaneously, we had our varnish removal unit, and this is what the filter stack looked like in that. So we really knew that we had something, and we made a point of documenting that, and we got in the practice of taking inlet and outlet samples simultaneously from the system while it was running, and ran these as patches, and were able to trend and to see a remarkable improvement of single pass efficiency, of varnish removal, and then that continued over time. So this was a great product, and it has been and continues to be a great product. Now, at this time, though, the testing and the reporting was a little bit all over the place. There was a few labs that started doing varnish testing, a few others came online, and everyone kind of had their own way of doing things. And as such, the results didn't translate very well from one lab to another. And sometimes the numbers, they use different scales, a different maximum. Um, Sometimes they used different things altogether. There was some that were doing RGB and giving numbers on a scale like that. Some stuck with the ultracentrifuge. Um, they had their own proprietary naming convention and numbering. And this made it pretty confusing for users in the field, especially if they were shopping around or using different laboratories at different times. Um, and the industry realized that we need a standardized test here that we can use to properly trend and document varnish. And that's where the ASTM D7843 came into effect, and that's exactly what it was. It was a set procedure that any lab could follow to achieve consistent and repeatable results. Um, and by this time, varnish had become quite a hot field. um, with many new products on the market. And that included things like electrostatic precipitators, agglomerators, ion exchange resin beads, additives, even anti-varnishing oils. And a lot of these things are still available on the market today. Um, we did notice with the lab in Denmark had been doing their own MPC tests before the ASTM standard as well, and when the final test was released, they noticed a few subtle differences that did tend to make um, shift the scale down, so to speak. So it seemed slightly easier to achieve better results. And this was something that was it did have an effect on the varnish, and it did seem to make it easier to get good numbers from a lab report. Um, so the many of these technologies did in fact show good effectiveness as it came back from laboratories, but that didn't always tell the same story, and made us kind of wonder, is this just a trick of lowering standards to make things seem better? And ultimately, it's the systems that tell the story. And we would have customers call up with scenarios like this, where their sample report would come back as normal, but their system was anything but. So, so what's going on here? How does this happen? This is something that we do see in the field. So why would a system seem fine sometimes, but not at other times when nothing else has changed? How can new oil get varnished so quickly after an oil change? And this is where the translation it starts. What I'll the title of my presentation, Translating Varnish. So um, it, I'll try and get into a little bit of breaking it down, maybe going backwards a little bit from the high-end science and the chemistry, but now bringing it back to practicality. So to do so, we have to get to know varnish on a cultural level and in the context of its own environment. So one of these contextual attributes is its cyclic nature. The cycles can happen for various reasons, and they can happen for more than one reason at a time. So this is a graphic showing a cycle we often observe due to the cleaning effect. Um, so as a system or a strategy takes the varnish out of the oil, there is a equilibrium that is always at play. And when varnish becomes plated out in a system, and you then take it achieves an equilibrium state with the varnish that's in the oil. So when you take the varnish out of the oil, that's going to take varnish back off the system that's been plated out and bring it back into the oil. So you do get these cyclic periods of rising and falling, and this is something that we've observed countless times um, using our varnish removal unit. We see a rapid drop and then an increase and a wave, and the waves can continue like that for some time depending on how bad the system is to begin with. So another cycle that we've observed before, this was a gas turbine control system, and um, they had some high numbers, and this was followed by an improvement. They thought, hey, we're doing great here, and then it resurfaced, and it was bad. It was clearly in the caution zone, and they needed to do something about it. So looking at a trend like this would make us question, well, what's going on here? This was with nothing changing to the system. But what we did observe is that this was a change, a cycle through seasons. So and the theory here is that in summer, the samples showed like there was a lot of varnish in the oil because it was pulling it into the oil, and in the winter, this was in a cold location in Alberta, and One could surmise that the surfaces of the tank or of various parts of the system that were exposed to the cooler temperatures, that they would collect the varnish, it would precipitate to those surfaces and cling to them coming out of the oil and not show up as reportable or as a serious problem on the sample reports. Come back into summer, that varnish transitions again and moves back into the oil, and suddenly it shows they've got a problem again. So these seasons really only hit it. It never went away. And users can often describe varnish in ways that the lab can't. So I'll even suggest the most applicable description is cheap varnish and expensive varnish. So cheap varnish is the varnish that's in the oil. That's the easiest place to remove it from. The expensive varnish is already stuck to the insides of your oil system. And this is going to cost something to remove, be it by filtration or flushing or opening it up and getting in there and physically cleaning it. Now, even the most expensive varnish is stuck to the places where you least want it. And that's the varnish that's going to cause operational issues and unexpected shutdowns. So once it forms, it doesn't just disappear. It may change phase, change where it's concentrated, or change its saturation point, but it never gets better without some intervention. In fact, varnish is one of its own catalysts to further varnish formation, making it a real slippery slope. So leaving varnish unmanaged in the system is a lot like receiving your credit card bill in the mail and then deciding you're going to save money by not opening it. Doesn't work like that. And varnish charges interest too. And because it takes time to build up, it also takes time to remove. So thankfully, up to a certain point, the process is reversible. The effect of temperature on precipitation became one of the keys to our varnish removal solution, and together with several other important discoveries, gave our cellulose filtration technology the ability to remove both soluble and insoluble varnish, something that mechanical filtration on its own cannot do. To put it in the simplest terms, we make our filter media the most irresistible place in the oil system for varnish to collect. And being able to see it captured in the filter media became one of ours and our customers' greatest sources of affirmation of what was happening in the system. So when the lab reports would come back good, but the filters look as bad as what you see on the screen here, we knew that we had to keep doing what we were doing because the system definitely wasn't clean yet. So apart from lab reports, how else do you know what direction you're headed? Figures and data can be useful, but I'm a strong believer in making use of empirical evidence. Okay. So I've got two samples here. I've got one that was after 16 hours of filtering with CJC, and one that was without any filtering. So I'm going to do a patch test of both of these so I can compare what they look like on a 0.45 micron membrane. I'm going to start with the clean one, or what I'll assume is going to be the cleaner, just because it's easier to go dirtier than cleaner as you go through the test, so it won't be quite as critical to clean between the stages. So I'm going to start with this one. First thing to do is thin it down. I'm going to do 50-50 with petroleum ether. So we'll measure that out here in our beaker. And I had these chilled for about a week in the fridge. And if there's any varnish that's going to precipitate, that would be the ideal way to do it. Basically 40 cc's of oil, so I'm going to add it up to the 80 mark. And this just helps it to pass through the membrane, also reduces the contaminants that we're not interested in seeing. And give it a good shake. Now I'm going to take one of my membranes here. We're left with the patch with the oil that's run through it.
Yeah, normally this is a test we use for varnish. It can also pick up obviously other like solid contaminants and whatnot, but the petroleum ether is what they use for the MPC test.